We'll now continue with section 1.8 and discuss an application of rational equations. This type of problem is referred to as a work rate problem. Our example reads, one hose can fill a swimming pool in 12 hours. The owner buys a second hose that can fill the pool at twice the rate of the first one. If both hoses are used together, how long does it take to fill the pool? There are two concepts that we need to be aware of before we can work this problem. The first says, and I'm going to write them here, the first says that the rate of work is the reciprocal of the time needed to complete the job. What this tells me in relation to this problem, the first sentence says that one hose can fill a swimming pool in 12 hours. So the rate of work is the reciprocal of the time. And so the rate of work of the first hose is 1/12 because that hose can fill the pool in 12 hours. We're also told that the owner buys a second hose that can fill the pool at twice the rate of the first one. So what is the rate of work for the second hose? So the first hose fills the pool in 12 hours. The second hose fills it faster. It fills it at a rate of twice the rate of the first one. So if the second hose fills it faster, twice as fast, it will work it in 6 hours. And so the rate of work is going to be 1/6 for the second hose. Now, the second thing that we need to be aware of in this type of problem is that the rates of work are additive. This means that when two things are working together on the same task, like two hoses filling the same pool, they will have a combined rate of work that is the sum of their individual rates. So what this means for us is that I can take the 1/12 and the 1/6 and add them together, and that is going to equal the combined rate of work. And so we're going to set that equal to 1/x. Because again, we're looking for the answer to the question. If both hoses are used together, so that's the 1/12 plus the 1/6, how long does it take to fill the pool? And so we need to determine what the rate of work is for the hoses together, and then we'll know how long it takes. So this gives us an expression that we can solve for x. So remember that the easiest way to solve this is to multiply by something that's going to cause the fractions to disappear. And so if we look at our denominators, we have 12 and 6 and x. So if we were to multiply both sides of this expression by 12x, then we should see our fractions disappearing. So let's look at that. So if I take 12x times 1/12, the 12s would cancel and leave me just an x. If I take 12x times 1/6, the 6 and the 12 make a 2, and so we would have a 2x. And on the right-hand side, the x's would cancel, leaving me 12. So I have x plus 2x, which is 3x, is equal to 12, and so the x would equal 4. Now remember, the 4 is the time using both hoses that it will take to fill the pool. So we're looking at 4 hours if we're using both hoses. Okay, so let's keep that in mind, and let's look at kind of a part B to this same problem. So it says the pool owner in example 6 is a bit clumsy and one day proceeds to fill his empty pool with the 2 hoses, but accidentally turns on the pump that drains the pool also. Fortunately, the pump rate is slower than the combined rate of the 2 hoses, and the pool fills anyway, but it takes 10 hours to do so. So he puts both of the hoses in and he's filling the pool, but he has the drain open as well. And so how long does it take the pump to empty the pool? So let's look at this. If we're putting both hoses in, we know from the last problem that the rate of work for both of the hoses, the x is equal to 4, that it fills the pool in 4 hours if we're using both hoses. So we know the rate of work for both hoses is going to be 1 over 4. Now, we also know that this pump has been turned on that's draining the pool. So if you think about the pump draining the pool, that's going to indicate subtraction. The 1/4 is what's happening with the 2 hoses in the pool, putting water in, and then we've got a negative 1 over x for the pump. Now, we do not know how long it takes the pump to empty the pool. That's what we're looking at in our question. So that's why we're using an x here. So the 2 hoses putting water in, the pump taking water out, and we know that the rate that the pool is filling is 10 hours. So we're going to put that in as a 1 over 10. Okay, so make sure that makes sense to you. The 2 hoses going in, the pump pulling water out, it takes 10 hours for the pool to fill up. And so again, we have an expression now that we can solve for x. So what do we need to multiply by in this case so that we can clear our fractions? So we have a 4 and an x and a 10. So if we think about multiples of 4 and 10, we could multiply by, let's see, so 10, 20, 30, 4, 8, 12, 16, 20. All right, so 20 would be the lowest thing that we can multiply by. So we can multiply both sides by 20x. All right, so let's check this and see. So we have 20x times a 4th. So the 20 and the 4 would reduce to 5. Multiplying the 20x times the 1 over x, the x's would cancel, leaving me 20. And on the right-hand side, the 10 and the 20 would make 2, and we have x. Now again, we're solving for x, so we are going to subtract the 2x from both sides. So that's going to give me 3x minus 20 is equal to 0. We'll then add the 20 to both sides. So that's going to give me 3x is equal to 20. Divide both sides by 3. X is equal to 20 over 3 hours. So the pump can empty the pool in 20 over 3 hours, or you could divide that out and you would come up with 6 hours and 40 minutes.